in this question, what we want to do is find the second derivative. So we've got to do a couple of little things here. So derivative of sine squared x. Again, remember this can be written as sine x all squared. So we're going to apply the chain rule. So 2 comes down, subtract 1 from the power, just gives us the sine x, multiplied by the derivative of sine, which is cos. Now, when we go to get the second derivative here, we can treat it as two separate functions, 2 sine x times cos of x. So derivative of 2 sine x, we keep that, derive cos of x, which is minus sine of x, and then plus the derivative of 2 sine x is 2 cos x, times cos x, leaves us with 2 cos squared x and minus 2 sine squared x. In b here, we've got the log of a cos function. So log function here, derivative of the function over the function. So derivative of cos x is minus sine over cos, which gives us minus 10 when we simplify it. And derivative of minus 10 is really simple because it's just secant squared of x. So just be careful when you've got to do the second derivative, that we're getting our rules correct and we're making sure we don't make simple errors. So this in question 5 here, if y is equal to x minus cos x, find its derivative when x is equal to pi on 2. So we'll find the first derivative. X differentiates to 1. Cos x differentiates to minus sine. So the minus at the front makes it a positive. When x is equal to pi on 2, substitute it in. 1 plus sine of pi on 2. And sine of pi on 2 is 1. So it just gives us 2. Then we want to find the equation, the tangent to the curve at where x is equal to pi on 2. Well, we've just done all that work. That actually just gave us our gradient. So we know our gradient's 2. X is equal to pi on 2. Y would be equal to pi on 2 as well, because we get pi on 2 minus cos of pi on 2, and cos of pi on 2 is 0. So that's just going to be pi on 2. Put in for the equation the tangent. There's our x and y values, pi on 2, gradient of 2, and then simplify it out to give us that function there. Question 6, if we've got e to the power of sine x, find the function of 0 and the derivative of the function of 0. So if we find the derivative of the function, gives us cos x e to the sine x, because it's the e to the sine x stays the same, multiplied by the derivative of sine x, which is cos x. When we put 0 in, sine of 0 is 0, which gives us e to the power of 0, which is 1, and derivative would be cos of 0, which is 1, and e to the power of sine 0, which we just said was 1 as well. So the derivative is 1. Again, the equation of the tangent of the curve, a point where x is equal to 0. Well, there's our point, 0, 1. That's our y value. There's our point, and our gradient was 1. And we can then just take the x across, or we'll take the y across, and gives us x minus y plus 1.